Hello, Tom from EveryStepPhysics.com. A problem in physics regarding a vertical spring, and I'm going to do a series of these over almost all the variables possible, and you can do your homework or whatever. You can certainly buy my programs for around $30 here, 350 of them. Load into your titanium calculator, and then you can pass physics easily and keep it for the rest of your life. Of course, you know, if you're young and in college, you're going to have kids your own. You'll have it forever as long as you keep the titanium and as long as you keep the programs. And you'll always be able to do these quickly, sensibly, and without great study. So let's do it. Physics in my menu here, and you type that in as the instructions come with all this, you know. You type this in, press enter, and you get to the menu. I've already scrolled down. You scroll down or up using the cursor. I've scrolled down already to save time. For springs, certain things you have to get used to in my programs. For instance, if you're dealing with bullets, you go to bullets. If you're dealing with collisions, you go to collisions, okay? And other things you can find, like for instance what they ask you in the problem, like acceleration or tension or velocity, final velocity or initial velocity. And in this problem here, you'll notice that they give you a force, 75 newtons, and attach it to a spring. I don't know how they do that. I mean, a force is a force. It's not, you know, you can attach a mass to the spring, but I mean, they do anything they want, and physics professors just dream up this stuff and then expect you to use algebra, and they throw something on the board like force equals mass times acceleration, and then give you a test on this god-awful problems, you know, that they never discuss on the board. At least my professor never did. But in this one, they give you the force, and they give you how much they're stretching the vertical spring by, which is 5 centimeters. Then they place the spring horizontally on a table, and they stretch it by 13 centimeters. So once you find the gravitational, constant, spring constant of a spring, then that's built that way. And so then they use the same spring, you find the spring constant in the first one here, which I'll show you, and then you enter that and go back and put it into the other program into horizontal springs. Okay, let's do it. We're at springs, pressing enter, and we're going to be vertical springs. Okay. And we're going to choose force and stretch, which is y. In a vertical spring, stretch is y. Most professors will say it's x, but they're wrong. X is for the x-axis on the a horizontal spring, and then y is for the vertical axis, but that's beyond some of those professors. Too deep for them, I guess. So anyways, you got a force and you got the stretch in vertical. Okay, let's do it. Press enter, and then we're going to enter the variables. We're going to enter the force. We have to press alpha first before you enter anything. And I've just pressed alpha, and I'm going to enter in 75 here, and 75, and then we're going to enter the stretch or compression that they give you, and that's going to be alpha 5. Press enter twice, and we're going to choose centimeters because that's what they give you. We need to convert that to meters, which I do here. I always show you what you've entered. You can change it if you want. I say it's okay. Number 1. Mass is equal to 7.6453, in case they ask you that, which they could. And the stretch, I give it to you again here, it's 0.05. spring constant then is this these formulas and calculations. Just please show work. Well, here you're showing the work, mass, gravitational amount, and the stretch, 1500 Newton meters. Okay, I'll give you the T in the period too if you need that, or the period can be converted to frequency in cycles. And then, so now we have the spring constant, 1500. We're going to go back to number one, go back here again, and now we're going to go down here to K, because we have the spring constant, and we have the new stretch of 13 centimeters. So we're going to choose that one. Okay, and we're going to press alpha. We're going to put 1500 for the spring constant, and we're going to enter the stretch in this one, which is alpha 13, and with the trick conversion 2 centimeters. Show you what you've entered. Okay, and the force is 195 newtons. Here we're showing the work. Here's the spring constant times the stretch, 13.13, 195 newtons. Okay, and the weight equals mass, so the mass is going to equal 19.878 kilograms. And we go back to a new problem, whatever you want to do. Okay, so anyways, go to my site, buy my programs, have a good time passing physics. And remember, I sell calculus programs too for the same thing for calculus. One of the most miserable classes ever. All right, have a good one.